In metaphysics versus science, they say that the all is omnipotent. It's all powerful. It's omniscient. So it's all knowing, and it's omnipresent. So it's everywhere. And then in science, they just say conservation.
What's up, everybody? Today on Universal Theory, we're going to be talking about conservation of energy. Before we get into that, I just want everybody to know that over the weekend, I've been thinking about this channel, and I've been thinking about the direction we want to take and the value that we're adding to YouTube. And the value that we add to YouTube and to your life is the fact that we combine science and these principles like we've been doing in our most recent videos. We will not be a science channel. We will not be a mystical channel. We will not be an astrology channel. We will be combining the two. We will not waver in this. If you don't dig that and you think that you can't just pick the meat from the bones, so to speak, then this channel isn't for you. I'm not going to waver in what I believe this channel is for. There's too many people that have reached out already that say how amazing it is that we have a channel that bridges these two together. So there you have it. That's what's going to happen on this channel. There's plenty of pure physics and academia channels out there. There's plenty of pure mystical channels out there. If that's more your bag, then go find one of those. Hopefully you stick around because we love you. We'd love for you to learn from us. We'd love for you to share in this experience. But if it, I'm not going to cater to that kind of an audience as much as I'd like to, maybe in another life. But here you get the best of both worlds, which I think is better than half. But it's only time shall tell. So yeah, conservation of energy is going to be the topic today. And as I just said, what we do is combine the principles. So what I'm going to do is just give a little background on conservation of energy. I know a lot of people talk about conservation of energy. I know that it's a topic of discussion, especially in the scientific community. Obviously, it's a law. This is one of those things. It's not a theory. It's not, the only part of it that's maybe theorized is something that we'll get into in another video, and that's the Everett interpretation, and does energy have to be conserved when we're talking about multiverses. But like I said, that's a whole nother video that we're going to be shooting. So conservation of energy, just to give a little background on it, is when you pick up a rock, like we talked about in the kinetic and potential energy, or whatever you pick up, and you drop it, the energy in that system from the potential energy all the way through now is going to be conserved because you gave it energy by lifting it. And then when you dropped it, it's releasing that energy via the curvature of space by falling down. And then once it hits the ground, you're going to have to take into account many, many things. All the physics problems that I did, I think my freshman year were like negate, actually pretty much for the whole undergrad is negate the wind. Like you can't worry about what's happening with the wind and friction. We thought about a little bit, right? We obviously dealt with some forms of friction. We didn't really deal with energy that's lost through, when something hits the ground, now the molecules are going to get energized a little bit, and there's going to be energy that dissipates through heat through that friction. And, we don't really get that far because then that becomes very dynamic. And especially if that rock breaks into a bunch of pieces, now you've got to calculate each one of those as its own kind of system and how much energy would be there, and it just kind of turns into a mess. So it's much easier when you just think about no wind, nothing breaks, you just pick it up and drop it. But essentially what's happening is energy is conserved now. The energy is always there, and that is very powerful in a scientific sense, and that is very powerful in a metaphysical sense, that this energy cannot be destroyed. It can't be created either. It can only change its form. It can only be transferred into a different state. So we have a system that now, if you're looking at it from a relative perspective, that's what you have to keep in mind, right? A relative perspective. If you don't see conservation of energy, your frame of reference is wrong. You need to be incorporating more variables, or you need to make sure that it is a closed system. Yes. And that's essentially conservation.
Mm-hmm. Yeah, in metaphysics, we have the concept of the all is mind, the universe is mental, and this mind represents the sum total of all energy in an infinitely closed system. Mm-hmm. and you cannot add to or take away from. And in an absolute sense, you can't change it either. But in a relative sense, everything is always changing. So like he said, it's about your frame of reference. Where are you viewing it from? Well, we're viewing it from the relative, even though we consider within the relative that the mentalism is an absolute because it governs the totality of our existence. So that's where conservation comes into play when it comes to mentalism, because in metaphysics versus science, they say that the all is omnipotent. It's all powerful. It's omniscient. So it's all knowing, and it's omnipresent. So it's everywhere. And then in science, they just say conservation.
They tidy it up a little bit.
Yeah, they sweep everything. One word, conservation. Everything is conserved. And then, like he was saying, it has to be a closed system for the energy to be conserved within it entirely. So if you're looking at a system and, like he said, if you drop this ball and it goes from potential to kinetic, the air molecules are affecting it. The heat that was generated from lifting it was affecting it. So there's energy going into this object, and there's energy coming from it, as well as when it hits the ground, and then some of the energy dissipates and gets absorbed by the ground, and then it activates those atoms and those molecules. So someone would say, well, that's an example of energy not being conserved, but that's because the rock was not a complete closed system.
Right.
So the all is mind, the universe is mental, equal in nature, different in degree. So all things are mind and all things have mentalism, and the energy is ultimately conserved within the ultimate mind. And there's a rhythmic oscillation between systems. If they're not entirely a closed system, well, we have the mind as the ultimate closed system, like a tank. And then all of this energy inside is conserved, but it's constantly being transferred from one thing to another.
Yep. Yeah, and take a minute to think about that, to think about what you ate earlier today, and now when you go to lift something from an energetic point of view, you just gave that thing that you lifted energy. You just gave that energy from the food you ate, and now if it's hanging out somewhere, it's hanging out with your energy in a potential state. And then if it falls down, someone knocks it down, it falls through the air, and it's releasing it through motion, right? And then obviously when it hits the ground, who knows what's going to happen to it? But your energy kind of is always ever flowing and ever moving, and that should be comfortable. The fact that this is a scientific fact, and people say, hey, you can't reconcile these two. Well, when you look at energy from a scientific, the conservation of energy from a scientific point of view, and you understand that energy can't be created nor destroyed, only transferred. Well, where did I come from? I had to have came from some transfer of energy. Oh, my parents. Well, okay. Well, sooner or later you get to the point of where, evolution or whatnot. So, and then moving forward, will I ever die? Your energy can't be destroyed. We know that as a scientific fact. So if your energy can't be destroyed and you think that there's any energy associated with your consciousness, then you're good, at least as far as the energy is concerned.